Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from indefinite integral, right? So here we have to find out the value of this indefinite integral where we have the integrand as sine inverse 2x over 1 plus x square, right? So here if we look at this integrand, we can easily see that here we have to make use of the method of substitution, right? And moreover we have to make use of an important identity from trigonometry, right? So let us start. So let us first call this integral as I, right? Now here what we will do, will put x is equal to tan of theta, right? So here we are making the use of a substitution method by changing the variable x to theta, right? So x is equal to tan theta, and this implies that theta is equal to tan inverse x, right? So now if we differentiate both sides, that is if we write dx over d theta, then we have secant square theta, because the derivative of tangent theta is equal to secant square theta, right? And here sec square theta can also be written as 1 plus tan square theta, right? And we can also write it as 1 plus x square, right? Okay, so now we have dx over d theta is equal to 1 plus x square, or dx over d theta is equal to sec square theta, right? Okay, now let us come to the integral I, and we can now write it as sine inverse, and here we have 2 tan theta divided by 1 plus tan square theta, right? And for dx we can write from here dx is equal to sec square theta d theta, right? So here we can write sec square theta d theta, right? Okay, now here we'll make use of an important relation from trigonometry, that is sine 2 theta is equal to 2 tan theta divided by 1 plus tan square theta, right? So this is an important relation between sine 2 theta and tangent theta, right? So here we can write sine of 2 theta, right? So we have sine inverse sine of 2 theta, and here we have secant square theta d theta, and sine inverse and sine, these two get cancelled if we take the principal value. So we have now 2 theta sec square theta d theta, right? And 2 being the constant, we can take 2 outside, and we have integral of theta sec square theta d theta, right? So here we have used sine inverse of sine say x is equal to x, right? Okay, so now our problem is to evaluate this integral, right? And here what we will do, will make use of the method of integration by parts. So now if we see this integrand, we see that this is the product of two functions, right? And this is the algebraic function, that is the polynomial function, and this is the trigonometric function, right? So now what we will do, we'll take this function as the first function as u, and this function as the second function v, right? And the integration by parts formula is integral of uv dx is equal to, if u and v are the functions of x, then the integral of the product of these two functions, where u is taken as the first function and v as the second one, we can write it as the first function, then integral of second function, then minus, and then we have integral of the derivative of u, and then we have the integral of v, and then we have to take the entire integral of this function. So here we have dx, right? So now here we have u is equal to theta and v is equal to sec square theta, right? So both are the functions of theta, and now we have to find the integral of theta secant square theta. So now our integral I is 2 times, and here we have theta sec square theta d theta, right? So we'll take it as u, and this function can be taken as v, right? So now we can make use of the formula for the integration by parts. So now we have 2 here, and this is the first function theta, integral of sec square theta d theta minus integral of the derivative of this function, that is theta, and then integral of secant square theta and d theta, and here also we have d theta, right? And now we know that the integral of sec square theta d theta is tan theta, right? So now we have 2 here, and the integral of sec square theta is tan theta, so we have theta tan theta minus, here we have integral of see, the derivative of theta with respect to theta is 1, and the integral of secant square theta d theta is tan theta here, and this is d theta, and we can have here the constant of integration, right? And now again here we have a simple integral, that is integral of tan theta is given by log of secant theta, right? So now we have 2 times theta tan theta minus log of sec theta, and here we have c as the constant of integration, right? So viewers, the value of this integral I is given by this expression, but this expression is in terms of theta. So now we have to express this expression in terms of x, right? So we'll make use of simple trigonometry to convert this function in terms of x. 2 times here we have theta, so for theta we can write tan inverse x, and here for tan theta we can write x, so here we have x, then we have minus a log of sec theta, right? And we know that sec square theta is equal to 1 plus tan square theta, so sec theta is equal to square root of 1 plus tan square theta, and we have tan theta as x, so we have square root of 1 plus x square, right? So here we have square root of 1 plus x square, right? And here we have c as the constant of integration, right? So now if we multiply these two terms by 2, then we have 2x tan inverse x, and here we have minus log of 1 plus x square and plus c, right? And here the square root get cancelled with this 2, because log of square root of 1 plus x square can be written as half of log of 1 plus x square, right? So this 2 and this 2 get cancelled, right? So this is the indefinite integral of this function, right? So viewers, this is how we solve this problem.